Hello and all, my name is Herr Technik, and today I'm going to show you how to create these beautiful bitmaps on any PIC microcontroller and some cool stuff that I added to this driver, such as these tiny bitmaps and some other things. So let's get started. So let's start with a quick explanation of how this driver works. For this example, I'm going to use a 128 by 32 pixel OLED screen, which is very popular and you can find it anywhere. Okay, the screen is organized horizontally in terms of columns. So the first column, which is at the leftmost part of the screen, is at index number 0, and the last column, which is at the rightmost part of the screen, is at index number 127. And then it is organized vertically in terms of pages. The top page is at index number 0, and the last page, or the bottom page, is at index number 3, at least in this case. But it turns out that each page corresponds to a sequence of 8 bits, aka a byte. And remember that in binary, we can only have two states. So a 0 would be represented by a black pixel, whereas a 1 would be represented by a white pixel. And the least significant bit of this byte is the top pixel, and the most significant bit is the bottom pixel. So as an example, the hexadecimal number 0x3a, whose binary representation is this one, would be represented by this specific column of pixels. So remember, the top pixel is the least significant bit and the bottom pixel is the most significant bit. So this is a much more complex synchronization of what I said earlier. Here we have 5 bytes, and remember that each byte represents a column, okay? A column of 8 bits. So the first byte would be represented as follows: the next one, the next one, the next one, and this is the final byte. And as you can see, it is a $sign. So now that you understand how this dryer works, let's take a quick look at the image conversion system that I implemented. So we are going to start with a normal photo like this one. This is my dog. Then we are going to convert that photo into a monochromatic bitmap. And finally, we are going to convert this bitmap using a special tool that I designed so we can finally get an array like this one, which is really useful because we can copy and paste it into PIC compiler and everything will work fine. Okay, so I'm gonna use my logo type as a example. I'm gonna open up Paint, I'm gonna resize the image, okay? So first I'm gonna trim the borders. So the image is more, well, it's smaller, okay? Then I'm gonna resize the image to 128 by 64 pixels. And remember that I do not want to maintain the aspect ratio. Okay, it looks fine. Then I'm gonna open paint.net, but remember that you can actually use wherever you want, as long as it gets the same effect. I'm gonna apply the black and white effect. And then I'm gonna modify the contrast, okay? So it looks more monochromatic, so to speak. Okay, I'm gonna save the image, and then I'm gonna open Paint again, but now I'm gonna save it as a 24-bit bitmap. This is really important because if you don't save it in this correct format, the program that I wrote will not work properly. Okay, now I'm gonna copy my BMP file, and I go to my selected test folder. Here I have a lot of BMP files that I used for testing. Okay, and I get rid of this duplicate. And now we have to open the command prompt of Windows. I'm gonna change my directory to test. I'm gonna run this application ssd1306.x, and I'm gonna run it with logo.bmp. And as you can see, it generated this binary output. And then I'll just copy and paste that bitmap here. But this is this is a boilerplate configuration that I use for this program. Remember that you have to define the size of your screen. Okay, then I'm gonna copy and paste it here. And this is the size, the name of the bitmap, and you have to refer to that name in the program. Okay, as you can see, both names match. And then I'm compile the program. Gonna open PIC programmer. I'm gonna check the communication. Okay. Then I'm gonna import hexadecimal file. I'm gonna write, and I'm gonna verify the program. Okay. So yeah, perfect. Okay, haven't discussed this so far. This is a diagram I'm using for the circuit. You don't have to add any pull-up resistors. Well, serial clock is connected to pin 18 and serial data is connected to pin 23. So if you don't know which pins are serial clock or serial data, just go search for the datasheet. And the final question is, what about tiny bitmaps? I implemented them because they're really useful for video games and animated graphical user interfaces. Okay, we are back at our folder. We're going to open up the command prompt again. And we are going to execute the program with our tiny bitmap. We are going to copy and paste the output. And we're going to paste it in PIC compiler. We are going to change our screen. And well, this is very important. We have to, well, these two values must be the same. Okay, 16 and 2 must be the same, in the same order. Let's compile and let's see. Okay, this is the final result. Let's use an animation. Okay, and well, this is a Pac-Man animation. So don't forget to subscribe and give me a thumb up, and see you next time.